Hello, Mr. Mailer here, your online math teacher, and welcome to my channel. Today we're going to be talking about using the law of sines to help solve for side lengths in non-right triangles. Although the law of sines will work for right triangles as well, but typically you're going to want to use just your regular SOHCAHTOA if you're trying to solve for side lengths in them. So let's get this going. So our goal is to be able to identify when we can use it and then implement it. Some notes with the law of sines. There's two different ways you can kind of look at the formula. You can think of it as sine of an angle over its opposite side length should always be proportional to each other. So if I pair angle A and side A, which are opposites, I should get the same ratio as if I did sine B divided by side length B. Similarly, since this is proportions, you can and flip all these fractions. You could look as a proportion of the side length to sine of the angle, and you're going to end up with the same thing. Now, we end up using these to solve for AAS and ASA triangles, but really, these are just triangles where you already know what all the angles are going to be, because once you know two angles in a right in any triangle, actually, you can always find the third one by subtracting the angles off of 180. So as long as you know all the information about your angles and know at least one side length, you should be able to implement the law of sines in a problem. So now let's see an example of this in use. So here I have a triangle ABC with side length C is equal to 4. So I'm going to put a 4 down here with my C. An angle of A is equal to 51 degrees, so I'm going to write 51 here, and an angle of C is equal to 57 degrees, so I'm going to put that 57 up here. Now, again, we can quickly find angle B in this case, so angle B is just going to be 180 degrees minus our 51 degrees for angle A and our 57 degrees for angle C. And if we plug that into a calculator and do our math, we end up getting that this is just 72 degrees. So I'm going to add that 72 over here to our picture also. So again, this is a triangle where I can see right off the bat, I know an angle and I know its opposite side length. Since I have that pairing and I know all my other angles, this is definitely a situation where I can use the law of sines. So I'm going to start off by trying to solve by setting up a ratio with the law of sines. In particular, since I know this pairing of this angle C and side length C, I'm going to write sine of the angle C, sine of 57 degrees, divided by its side length C of 4 right here. So I tend to always use the version of the law of sines with sine of the angle in the numerator, or you might teach it differently. I tend to just teach this with one way instead of having my students memorize two formulas. So next up, we want to decide which side length we're going to solve for. It does not matter which side you solve for with the law of sines. Angles are a little bit more technical, but sides does not matter. So I'm just going to pick side length A to begin with. So I'll do sine of angle A, which is 51 degrees, divided by side length A. So to be able to solve, I need to isolate and get A by itself. So what that means is I need to get A outside of the denominator. Now, I'll solve this one in a little bit different way than the next side length, only to illustrate two different ways you could go about algebraically solving this question. So, what I'm going to do to start is try to get rid of all the fractions. To do that, I'm going to cross multiply by A and 4 to clear these fractions. And when I do that, I will now have A times sine of 57 degrees is equal to 4 times sine of 51 degrees. So I've moved the 4 and the A outside the denominator. Now what I want to do is I want to get A by itself. So to do that, I need to move away that sine of 57 degrees. And since A is being multiplied, that division will undo our multiplication. So we can divide both sides by sine of 57 degrees. So divide by sine of 57 degrees. That will cancel. And we will then end up with A is equal to 4 sine of 51 degrees, all divided by sine of 57 degrees. And again, this is a number you can now take a calculator, just plug right into it. So I do a 4 times sine of 51, all divided by sine of 57. And I get that side length A is approximately 3.71. 3.71. So I've solved for side length A. I'll now go back and I will solve for side length B. I'm going to do this a little bit differently. I'm going to start the setup the exact same way, but I'm not going to cross multiply. So I'm going to show you another way to deal with this that maybe some of your students, or if you are a student that is a little bit less comfortable with fractions, this might be a little easier for you. So I'm going to start with my sine of 57 degrees over 4 again, because that was the pairing I started with. Then I'm going to set this equal now to sine of angle B, which is 72 degrees, all divided by side length B. Again, our goal is to get B by itself. So this time, I'm only going to move the B outside of the denominator. So since it's in the denominator, to undo that division, I'm going to multiply. So I will multiply both sides of this equation by B. My B's will cancel. So I will now have B times sine of 57 degrees divided by 4 is equal to sine of 72 degrees. And here's my other method. So B is now multiplied by this ratio of sine of 57 divided by 4. So I can undo that multiplication to move it away just by dividing everything by this fraction. So I'm going to divide by my sine of 57 degrees, all divided by 4. I'm going to do this on both sides, sine of 57 degrees over 4. So that division will undo our multiplication. So now I'm just going to end up with B is equal to sine of 72 degrees, all divided by sine of 57 degrees divided by 4. So I have a fraction inside of a fraction, but that's fine as long as I'm going to approximate this now with a calculator, which I'm going to do. I could have cross multiplied at the beginning, but maybe this might be a little bit easier for you. Either method is fine. I would just check with your teacher to see if they care about this exact form, having a fraction and a fraction. So sine of 72 divided by, and then I'm going to put parentheses around the denominator in my calculator to make sure it reads this correctly. Sine of 57 divided by 4, and that gives me, if I plug in correctly and don't give myself a calculator error, it gives me about 4.54. So this is approximately 4.54. So here was 2 examples of me solving for side lengths with the law of sines. And that's about all there is to it. So I hope you found this video helpful. Like and subscribe, and I'll hopefully see you in another video.